Welcome to the TOEFL Listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor, or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Professor Carter. Thanks for meeting with me. I wanted to discuss my project on 3D printing in manufacturing and get your feedback on the production strategy.
Good afternoon, Mark. Tell me what you have so far. Are you focusing on prototyping or on moving to small-scale production?
Both, actually. The literature I read emphasizes additive manufacturing for rapid prototyping, but I want to show how it can be used for end-use parts in small batch production. I am comparing fused filament fabrication, selective laser sintering, and direct metal laser sintering for different applications.
That is a sensible scope. Make sure you compare manufacturing metrics, not just the printing technologies. Think about lead time, cost per part, material properties, and quality control. For example, DMLS, which is a metal powder bed process, is commonly used for aerospace fuel nozzles because it allows complex internal channels and good material strength.
Right. I plan to include case studies. I was looking at the fuel nozzle redesign where they used topology optimization and DMLS to reduce parts and weight. I want to analyze when additive makes sense versus traditional subtractive methods or casting.
Include decision criteria. For instance, additive is ideal for geometries that require internal lattices or conformal cooling, and for parts that benefit from mass customization. But for very high-volume parts with simple geometry, injection molding still has lower cost per unit.
That raises a question. How do we quantify break-even volume for additive processes? I know build time and machine hourly cost are factors, but what about post-processing and quality assurance?
Good question. The break-even analysis needs to include machine depreciation, operator time, support removal, heat treatment, surface finishing, and inspection. For metal parts, post-processing like stress relief and machining critical surfaces can add significant cost. For polymers, sanding or vapor smoothing affects finish and tolerance.
I am planning to run a cost model that includes those steps. For a polymer bracket example, I want to compare FFF with SLS. SLS gives better mechanical isotropy and no support structures, but the powder handling increases operational complexity.
Exactly. SLS parts often have better mechanical properties in multiple directions due to the powder bed process, but FFF is cheaper and accessible for prototyping. When you write your model, consider build orientation too. Orientation affects surface finish, the need for support structures, and mechanical anisotropy.
I ran a simulation where reorienting a part reduced support volume by 40% and cut build time by 20%. However, the part needed better surface finish on the mounting face, so I had to add a machining operation after printing.
That is a realistic trade-off. Orienting the part to minimize supports can save material and post-processing time, but may expose critical surfaces to poorer finishes. That is where hybrid workflows are useful. Print near net shape and then do CNC finishing on mating surfaces.
I want to include real applications beyond aerospace. For example, dental implants and custom orthopedic plates use titanium-printed parts. There are also automotive examples like lightweight brackets and tooling inserts for short runs.
Yes, Medical implants are a great example of mass customization, where additive excels. Porous lattice structures for bone ingrowth are possible with electron beam melting or DMLS. In automotive, you see jigs and fixtures produced additively to speed assembly and reduce lead time for new models.
About quality control, what non-destructive methods should I discuss? I know CT scanning is used for internal defect detection in critical metal parts.
CT scanning is important, also in process monitoring like melt pool sensors, and layer-wise imaging help catch defects early. Mechanical testing for tensile strength and fatigue testing are necessary for qualification. Standards and certification processes are still evolving for many industries.
I will highlight standards progress. One more technical challenge I want to cover is residual stresses. When you print metals, thermal gradients can cause warping and tensile residual stresses.
Discuss strategies to mitigate that. Preheating the build plate, optimizing scanning patterns, and adding support structures that act as heat sinks are common methods. Also, post-build heat treatment like stress relief annealing is often required.
For my conclusion, I plan to recommend DfAM principles, such as using topology optimization, consolidating assemblies to reduce fasteners, and designing lattices for stiffness while lowering mass. Do you think that will make a compelling argument for manufacturers considering additive?
Yes. Emphasize design for additive manufacturing as a cultural shift. Engineers must think differently about part geometry and tolerances. Also point out supply chain benefits, like on-demand production of spare parts, which reduces inventory and shortens lead times.
I will. Finally, could you suggest sources for reliable production data on machine costs and part quality for my model?
Look at industry white papers from machine manufacturers and independent studies from research labs. Also examine case studies from aerospace and medical suppliers, where they disclose process parameters and cost drivers. If you need specific numbers, I can share lab data from our additive manufacturing facility.
That would be very helpful. Thank you. I will draft the model and bring a sample calculation to our next meeting.
Good. When you prepare the sample, include a sensitivity analysis on material cost and post-processing time. That will show under what conditions additive becomes favorable. See you next week, Mark.
See you next week, Professor Carter, and thanks again for the guidance.
Listen again to part of the conversation, then answer the question.
Orienting the part to minimize supports can save material and post-processing time, but may expose critical surfaces to poorer finishes.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit spinta.org.